All right, thank you for coming. Good morning or afternoon, depending on where you are. This is the Energy Storage Partner webinar with Discover and Morningstar. My name is Mark. I work for Morningstar, and I'm here to introduce the team. From Discover Battery, we have Derek Pettingale. He's the Director of Product Development at Discover Battery, along with Brendan Sauer, who is the Product Line Manager at Discover. And then we have Morningstar's Jake Sherry, who's an Applications Engineer here. So Jake's going to start off, and then we'll turn it over to the Discover team. So take it away, Jake.
All right. Thanks a lot, Mark. Hello, welcome everyone. So just before we dive into too deeply, just going to give you a little bit of a background overview on Morningstar for those of you unfamiliar with us, put into context the creation of the Energy Storage Partner Program that is showcasing Discover Battery today. So Morningstar is a company. We have over 4 million products sold since 1993 when we were founded. We are known for having exceptional reliability. That's sort of the main identifying characteristic of Morningstar Products. We have the lowest failure rate in the industry, and proudly tout that every day. We are the leader in solar charge controllers. And in so we actually have the widest and most diversified product line of solar charge controllers. We have over 30 different models falling into 7 different product lines. Our products are sold in over 100 countries, and again, mission critical applications are what we seem to be our bread and butter. We do residential applications as well, including rural electrification. In fact, we are proud to have participated in the largest known off-grid residential project in the 40-year history of off-grid PV, which took place in Peru. We delivered power to over 200,000 homes and 3,000 community centers, bringing power to over 1 million people. We also support commercial and industrial applications, including telecom, oil and gas, security, and then also some recreational applications, mobile, marine, agricultural, and of course, many more. So with that said, let me give you a little bit of overview of our product line within the family of solar charge controllers we offer. We have both PWM and MPPT solar charge controllers. The PWMs you see listed here on the left, including the ProStar and TriStar, and then we have the MPPT variants, the 4 listed here. All of these 6 model families in total are compatible with lithium batteries, and we'll talk about that as we go throughout this presentation. So just to back up a little bit and give you some insight into, maybe it's a little bit of a review for some, but what the charge controller does within the system, traditional off-grid solar system, we're converting the PV panel voltages to the proper output voltage needed to charge the battery. Of course, this manages the delivery of current to the battery and prevents overcharging. Also, peripherally, we provide some load management capabilities, including lighting control. If you have, lights you want to turn on and off at scheduled times of the day. And then you also have, an inverter shown in this system. This would be for systems with AC loads, but you could have just pure DC loads running through the charge controller, which would be another common off-grid system, especially in industrial applications. Really, in all, the right controller is a very important selection in making sure your system's going to be reliable and it's going to extend your battery life. So it's a decision you don't want to take lightly. You want to make sure you have all the information at hand to make the best choice of product. The wrong controller selection, again, is going to be reflected in the overall life of your system, which will be greatly diminished, including the significant expenditure you put into your batteries. So again, just to elaborate a little bit, the charge controllers come in primarily two different flavors. We have the MPPT charge controllers, which stands for maximum power point tracking, and then we have the PWM charge controllers, which stands for pulse width modulation. So starting with MPPT, when would these be the ideal choice for your system? Typically in areas where you have intermittent sun, you have maybe inconsistent shading effects throughout the day, clouds rolling through, a certain unpredictability to it where you're really trying to flatten out the production in the most predictable way possible, for certain periods of the day. And that's when MPPT comes in handy, especially in cold weather climates. And the reason that is due to the effects cold weather has on elevating the voltage output of the solar modules. As that voltage tends to rise, it puts more strain on the conversion needed to bring that voltage back down to the battery, and you want to do it as efficiently as possible. And so MPPT, being sort of an intelligent DC to DC voltage converter, can effectively preserve your power output in the most efficient means possible from the solar array to the battery. And again, this allows you to use higher voltage arrays, so you can stack more modules in series and reduce your overall wiring costs and balance of systems needs as well. All in all, you're looking on average probably 5 to 15% increased yield using MPPT versus PWM. You can get as high as 30% in some cases, so I wouldn't rule that out. And then moving on to the PWM controllers, these are very consistent and reliable controllers that operate, very predictably throughout the day. Again, it's going to perform best in warmer climates where temperatures are very steady. You don't see a whole lot of volatility, big temperature dips throughout days when or periods when sunshine is available. So they regulate very effectively and efficiently, especially in warmer climates, and they're very cost effective as well. Our PWM charging is a patented design. It delivers constant charging, so you're not actually turning on and off a charging faucet, so to speak, which can lead to inaccuracies in charging. So we do it very intelligently. So what this brings me to is basically every day at Morningstar, in recent times, about 30% of our customer system inquiries have now started to inquire about the use of lithium in certain remote solar applications. There are several aspects of this that appeal to our customer base, one being, the extended cycle life rating, but also the partial state of charge benefits, which is fairly common in off-grid applications. And again, what this means to our end customers, especially, industrial applications as well, where they're really trying to limit the number of site visits needed, this provides more autonomy to that system operation, and that's very desirable. And one of the most common requests our customers make, we give out customer surveys and we collect feedback through support logs and so forth, is that they are really looking for a little bit of hand-holding and from the manufacturer, being Morningstar, utilizing our expertise to make recommendations on what the compatible charge settings would be for a given battery, lithium battery system. That was really the impetus for us creating the Energy Storage Partner Program. And so what we aim to do through this program is, one, assure system designers that Morningstar has basically done it all for you. We've worked out all of the compatibility and interoperability constraints. We, again, provide that peace of mind to the installer, and then make it a lot easier and less complex in terms of the actual integration and implementation of those settings. And all in all, we are providing the end users of our products and other battery systems as well with a more proven, better documented, and better controlled energy storage system. That's what we're going for, to make the whole overall operation of all components involved more reliable. So with that said, Discover plays a big role in this partnership program, and we are proud to introduce them today to talk to you about their technology. With that, I will hand it over to Derek.
Hello, and good morning, good afternoon, good evening, depending on where you're calling in, to our audience around the world. My name is Derek Pettingill. I'm here with Brendan Sauer. We'll take you through the Discover portion of this. But before we do, wanted to thank Morningstar for this opportunity in their efforts to set up this opportunity. So thank you again. Discover, we're a battery company. We manufacture batteries. We may not be the best and biggest brand name around the world, but we have a pretty wide offer and a very important offer to introduce you today to the off-grid solar world. Our company is headquartered in Vancouver, Canada, and we have manufacturing sites throughout Asia, sales and distribution offices in Europe, Africa, and Asia as well. Our portfolio is pretty large. We'll spend quite a bit of time today talking about our lithium-ion batteries for traction, or for stationary rather. And additionally, we have a Drycell battery, which we'll introduce briefly, and tubular OPZ batteries we'll introduce briefly, suitable for off-grid. Additionally, we do automotive batteries. We're not going to talk about those today. Tubular. So AAS Tubular, we have a number of sizes in this, but our primary products are the 32, 44, and 59. These are 2-volt OPZV, which means they're gel inside, so maintenance free. We offer them in systems, either 48 or 24, with racking and interconnects. We stock those in North America, which is one of the very few companies that do that in the North American market. Our second product, the workhorse product for solar and most applications, is our Drycell brand. These are some of the more popular versions up there. The 225 6-volt, the L16 version 6-volt, and then the 8D 300 amp hour 12-volt. Some of our most popular models for solar in lead product. The product that we're going to spend most of today talking about, however, is our lithium-ion product. We have 2 models that we bring to this space, a 48-volt, 6.6 kilowatt, which is 130 amp hours at 51 volts. It's a C1 rating for that. And then it's a sister product at 24 volts, 2.8 kilowatts, 110 amps on that. There's also a few accessories that go with that. Make brief mention of the wall mounting bracket, which enables the battery to be mounted to the wall in a similar fashion as the inverters are, with back plate and then a mount onto the plate. Additionally, we talk a little bit about our new product, the LYNK gateway, which is an enabling product, quite important to us. So we'll get into that later. But this is the general lithium offer for the marketplace. First off, these batteries, they're focused on off-grid, whole home backup, and microgrid. So to identify where they belong, we're looking for the products that you see on screen there. Morningstar solar charge controllers, obviously an off-grid product. We welcome that. That's our space. Schneider Electric, SMA, Victron, Studer, Outback, Magnum, all prime candidates for partnership with our battery, and where they are, we should be too. That's what we're looking for. The product, the lithium ion product, has basically 8 attributes, of which we'll go over in a little bit of detail today. Here they're all listed in note form. This is up front and center on our website, so if you need a refresher on some of the features and their benefits and function, this is the place to go and see the same chart. The first of the features we call SENTRY, really gets to reliability, safety, and certification. So we've chosen the lithium ion chemistry for our battery. This is the safest, most stable of the lithium ion. This is the one that you really want out there. Its thermal stability is the best amongst the lot of lithium ion. We are certified to UL 1973, which is important. This is the stationary certification for a battery pack. It's not a cell rating, it's actual pack rating, which is important. If you're all the way in the United States and California, this is going to get really important soon, as if you do not have this, you will not be able to gain subsidy support for your product. Additionally, we have UN 38.3, which is the important legal requirement for safe transport of lithium-ion batteries. So we cover both of those very important ratings. The AAS battery system has a very sophisticated BMS internally. We broadcast and manage state of charge, voltage, current, temperature, and the faults. Additionally, as with most lithium batteries, these are maintenance-free batteries. So the feature functionality that we've termed JUICE, really enhanced runtime there, really talks about the usability of capacity. So we have 100% depth of discharge capacity of this. So and the 6.6 kilowatts is available to you. And you can go to 100% of depth of discharge. Unlike the lead acid batteries that commonly using are usually around 50% depth of discharge, potentially up to 80% depending on the type and style in there. This means that 20% or sorry, double the energy is available to you in the same amount of kilowatt nameplate rating there. So be purchasing less kilowatt hours to get the same amount of energy out and same kind of runtime. The batteries are designed for a very extended period of service. Our design life is targeting some 20 years on that. And as you'll see in the statement below, our performance warranty covering 10 years on that. So these are maintenance-free batteries. One of their design features is that they operate continuously in a partial state of charge. They don't need to be at 100% of discharge or discharged fully. You can do as needed, as pleased on that. That is a significant advantage in off-grid world where charging from sources is not always reliable on that. So partial state of charge is a very beneficial feature for off-grid, and we have it there. Our warranty supports this, so we have a 10-year 38 megawatt throughput warranty to 60% of original capacity there. So even if you go through that 38 megawatts of energy throughput, you will have 60% of the capacity remaining or better to continue using the battery. That's not the end of its actual working life. Another feature is related to efficiency. We call it MISR. The lithium ion is an extremely energy efficient battery. Its ratio of energy in to out is tops. It's some 98% or thereabouts when it's new, for a lifetime of 95% round trip efficiency. This is some 30% better than your lead acid battery lifetime RTE, which averages out, according to studies, around 65%. That 30% is worth a lot off grid. it means that you're just needing and using less energy and wasting less energy in the process of charging and discharging. That also is a support for what we call rapid charge, which is the capability of fast charging this. So the Discover AAS battery can accept a continuous charge of 1C. That's the full rate. So the 6.65 kilowatt battery is 130 amp hours at 51 volts. So you could put 130 amps into the product at 51 volts, no problem. It will accept that. That is extremely high and extremely fast recharging. It's one of the significant advantages of our battery, is its ability to charge very, very fast. In effect, that means for solar applications off grid that the arrays will be more productive. They can be smaller in some cases. And then if you're relying on diesel generators to provide the source AC for recharging, you're going to have a reduction in diesel consumption as well from this particular effect. Here we look at proof point on that. So on our website, we have a case study available called Living Off Grid. It's actually a series of papers tracking an off-grid system over a number of years and the evolving learnings of the owner of the system there. But the first and foremost point was the speed of charging and the impact on generator run hours. As you can see in the graph there, the green line is the lithium battery. It's fully charged within about 180 minutes of time. The other batteries, they're age lead and new lead batteries, stretching out well over 600 minutes and still not a full 100% charge. That's costing an individual a lot of diesel fuel to continue on that. So the savings can be incredible with this. Probably one of the most important and distinguishing feature for our battery, why it's really a battery targeted well at off-grid and for whole home backup, is its capability to support surge, the surge requirements of inverter chargers out there. We call this feature rush. So not only can it accept 1C charge, it can also discharge at 1C, which again is 130 amp at 51 volts. Beyond that, it can do peak power, momentary peak power of 2.3 times that, which is 300 amps, and that will support many of the larger inverter chargers that we showed earlier there. Typically, it matches very well at a one-to-one basis for an inverter under 5 kilowatts, and then above 5 kilowatts, we get into some larger systems, and we'll show you a little bit about them, how to do that coming up. But surge power, this is a distinguishing. There are other lithium battery products on the out there on the market, but many of them, the vast majority, cannot handle peak current much more than 1C in some cases, let alone 2.3 times C rate. Additionally, our batteries parallel very well. Scaling is very simple. If you've installed a lead acid battery, you can pretty much install our battery. The installation of cables and sizing of cables is exactly the same as a lead acid system. On that, there's really nothing new to learn there. There's no fancy system that needs to be employed on there using a bus bar system or a series, parallel connection batteries. No problem with that. The advantage that we have here is that our ability to do peak charge, continuous charge, and discharge capacities scale very, very easily. You have 2 batteries, it's 2 times. You have 3 batteries, it's 3 times that. This is because we have a BMS on each and every battery, and that they communicate with each other. So we're able to do this. We don't require a centralized BMS system or anything like that. Again, this really makes it very easy to install when you compare it to some of the other rack-mounted and enclosure-based systems. So to recap, we can do what we call a closed loop system, requiring a LYNK gateway. We can put about 20 batteries on that, reaching about 133 kilowatt hours. That 20 number can be extended a little bit. There, it's really about how much data is being transferred around on that rather than the power. As you can see, if we do an open loop without the communications to the inverter on that, the kilowatts are unlimited. It's really just like a LED system on that. So we're going to get into a little bit of detail on closed loop and open loop, as this is an important understanding. So when you're starting out with our system off-grid, really battery sizing is the first place you stop there. As folks are well understood, autonomy is the primary concern. So calculating autonomy needs are the same as they always are. Get the load profile and divide by the kilowatt hours of the battery and come up with a number of batteries, assuming 100% depth of discharge usage. In our case, you divide by 6.6. However, we need to also consider the peak surge capability, the continuous AC output of an inverter, and its full charging capability. So calculating those numbers there as outlined in the 1, 2, 3, 4 steps, doing that simple math will give you the number of batteries there, and simply out of those 4 calculations, you pick or select the number of batteries that's highest. That delivers a system and that provides batteries that will support the peak capabilities of that inverter, charger, solar charge controller system out there. Solar charge controllers, they don't have peak and needs on that, but if they're included as well as an inverter charger, you need to add them into the total amount of energy being delivered to the battery. So if the charger and the inverter is 100 amps and the solar charger is giving 50 amps, your total input to the battery would be 150 amps on that. So that is an important sizing of system. This is outlined in application notes that we publish regarding integration with inverter chargers, and we're including more and more of this information. If you don't size the battery system to its full capability, if it's just there on the edge, probably the system will work just fine. Derating of some of the system capabilities may be necessary to fit it in. There are other ways of accommodating this as this sizing system looks at the full peak capabilities. Configuring the batteries, as I said earlier, the installation is quite straightforward. If you've installed a lead acid battery, you can install our lithium battery. The only significant difference is the communication. So there are a number of ports on the front of each battery in between the DC connections. One of those is COM1 or AAS port. That by daisy chaining that between batteries, you're allowing the batteries to talk to each other and behave as one unit. It'll assist with the balancing of the system. Included with our product when you take delivery of one of the batteries is the splitter that enables the addition of a second battery, and then the termination. This is a CAN bus based network, so termination is required on that. So that is fairly straightforward. Configuring the inverter or the solar charge controller, open loop, this is like the same as a lead acid. You can program any inverter charger. We have a large number of application notes on our website. We're going to come later in the presentation where Morningstar is going to talk about how to program their solar charge controllers to do this. This can be done pretty much with any product. I'll refer you to the note on the setup on that. Closed loop is much more interesting. This is where the network is then linked to the inverter chargers and the solar charge controllers, and the information is automatically processed. And really, there's not much to do in terms of setting, as everything becomes automatic when you go closed loop. To go closed loop with an inverter or solar charge controller, we use a protocol translation device that we call LYNK. Small a box there. The box itself will take our AAS bus protocol, and then in the actual little box, you put in a number of cards that are system specific. So in this case, we're in development with Morningstar card, which would automatically translate all the variables and information into the language used by Morningstar product, and there would be really no further setup or required. It's quite simple on this. We have a number of other products. You can see that on a website or get in touch with us for that. What this does is really broadcast the state of charge, the voltage, temperature data to the system, so that it can use that. The LYNK device additionally has LEDs on the front of it that give you a visual indication of state of charge. Because our battery each one has a BMS internally to it, it's constantly calculating and broadcasting its own state of charge. So that's a digital calculation. It's highly accurate, far more accurate than we've ever seen before in terms of SOC accuracy for battery systems. It's one of the great advantages of using these products. One of the last sort of and very important things is, because of this full integration, when you go using a LYNK and you do closed loop information, the product itself can perform at a more optimized level. So you can see a graph here. This is using a Schneider product, but it represents what happens. Here we have two lines. One is the battery open loop. We did not plug it into the Schneider product, and then the second one where it is plugged directly into the Zambus network that Schneider uses. And you can see that by enabling the communication over and it accelerates the charging process by almost 25% in this example there. So this is over and above taking advantage of the faster charging rates that lithium can accept. This is just a tuning of the charging ability there. By broadcasting that information to the inverter charger, it can raise the voltage, for example, to put more energy back in and do it at a faster rate while maintaining the temperature profile required, and so on. So this can be a very interesting accelerating advantage where the pairing of our battery and a particular inverter charger is even more accelerated performance than just 1 + 1. It becomes a 1 + 1 = 3 type of equation. Here, I guess that sort of concludes some of the major feature overviews and performance overviews. Really take an interesting look at what makes a lithium battery good for off-grid. So we've put up our features and some of our specifications up there, and questions that you, the purchaser, the user of lithium batteries, should take in consideration when selecting the battery out there. So first up is safety. Obviously, lithium ion is the safest there, a UN requirement. A certification, in this case 1973, is ideal for looking at that. Also, to look at the specification of the other batteries in comparison to their useful capacity. Often they will only provide a useful capacity at 80 or 90%. So you have to check the fine print on that. Ours is 100% at 6.6 kilowatt 51 volts, 130 amp hours. Then the voltage range that delivers 100% SOC and DOD is at 48 volts is rather important and telling on the capacity and capability quality of the other product there. So our battery delivers 100% stated charge at 54.4, which is quite a reasonable voltage. You'll see other batteries with much higher voltages there, which will actually stress the voltage cells, the cells in the pack, and lead perhaps to premature demise on that. Our battery at 48 volts is 90% depth of discharge. And 48 volts is significant because that's the low battery cutout of a majority of inverter products out there. So have a look at that number and where that happens. We can go as low as 44.8, which is our 100% DOD there. So it's important to note where the product tops out at. Then the next three are really related to the quality of BMS and an off-grid product, looking at the C rate, how many amps it can actually put through. You will find significant differences between batteries, particularly the module style battery products that go into enclosures there. Their rates of charge and discharge are much lower on that, requiring a larger number of the modules to be used to get the charge, discharge and peak capacity to match up with the inverter chargers and solar charge controllers used out there. So again, does those peak charges, etc., are they scalable? And how do they scale on there? That's an important. Many of the enclosure systems are restricted by the BMS of the enclosure rather than the module itself, and so on and so forth. So it can be complicated to get peak capacity and a large charge and discharge out of systems if you're involved in something above kind of 10 kilowatts of product. There, ours has an internal BMS system, so we don't really face this challenge. We linear scale our peak charge and discharge amps, so pretty simple on that. Another thing that is very confusing with lithium batteries out there are the warranty cycles that are put on a lot of the data sheets. Typically, this is really irrelevant information for lithium ion and really impossible to measure if you look at the warranty support documents on that. There is no way to measure cycles in many of the lithium-ion batteries that are promoted out there. We really don't restrict. We have no restriction on partial state of charge on that. Again, our warranty supports throughput of energy. So throughput, that's the amount of energy put in charging and the amount of energy discharging added up. And we have a performance warranty of 38 megawatts throughput on it. Our digital BMS will log this information for you, and we can get it out of that, and it can be communicated on that. Really, that's what some of the communication systems are all about. Installation options: can you do a drop-in lead acid with the battery? Or do you only have to, or can you only use communication? Some of the battery systems will not function without a communication system with the inverter charger. Some batteries have no communications out there, and there are advantages and disadvantages to all of that. In our system, you can do it as either way. You could drop in lead acid with no communications, or you can set up communications with LYNK. Whatever you like. We also have a fairly flexible requirements. Our product is rated an IP55 that protects for general water spray out there. That's a pretty good rating for any off-grid battery room or building that's less than perfect out there. We have communication of SOC as we spoke on. Many of the other products do not do this. Most of the other products in terms of lithium do not offer data logs or extended access by service techs. We do that. We have a software-based product called AAS Dashboard that we provide to technical support personnel. They can directly access the BMS within the battery, get data logs, history on that, and assess cell issues, etc., and performance in there. It's a tremendous advantage for troubleshooting out there. It allows to do work in the field and to do it accurately. Additionally, our product is designed such that the BMS is a replaceable unit. So field service, should there be an event where the BMS is damaged, the entire battery does not have to be removed and replaced. The top has to be taken off and a board swap takes place. Much, much easier to execute in locations around the world. And finally, really looking at that parallel capability of the battery, really what can they do? These are all sort of a summary of very important attributes there. Additionally, point direct you to our website. Here we have an important tool up online which allows people to assess the cost comparison. Everybody wants to know what's the cost on that. So discoverbattery.com/solar, you'll see the link there. Be enabled to go and use this tool. You put in the system data, the competitive battery you're looking at. That can be a lithium, it can be nickel metal, it can be another type of lithium, or even lead up there, and put in your pricing information and cost information and see what the total cost of ownership really is. And then print out the analysis there. And it's designed so that an installer can present this analysis to a customer and allow them to make a realistic choice, because 9 times out of 10, the answer is going to be that lithium over the lifetime of your product is going to be a much lower total cost of ownership. And this allows the installer to put that information in front of a decision maker in clear terms. Sort of wrapping up things here, I'll be handing back to the guys on from Morningstar here. Just highlight a few of our applications out there. Lead acid replacement. We do this all the time. Typically the batteries are worn out, and we get a much higher efficiency. And in this particular case, and it was all about reducing generator runtime and how that affects the case study. So you can read about this particular one. It's a case study online on our website. They have quite an interesting system with quite an array of components in it. A lot of detail and very interesting talk and points on what it's like to live off grid and do a replacement to lithium. More recently, Puerto Rico was in the news a few years ago. There's a lot of activity building grids there, rebuilding the electrical system. We've been engaged in quite a number of projects there. This is one of the highlight projects, a water pumping station that's completely remote and off-grid and essential to community there. Now it's fully backed up system and able to be run off-grid by solar system and the inverter charger system out there. They're also able to get a lot of information using the LYNK system on that and find out what it's doing and how it's performing and check on it. The efficiency of RapidCharge is significantly important to use the solar system that they have there. Whole home. This is a whole home application, a very popular application throughout North America. This using a number of inverters for very high surge capability, because the entire home backed up, not just protection of certain circuits in the home, but they do the whole thing. They're really looking at the surge capabilities there. It's a big deal. This particular customer swapped out another brand of lithium product because it had no communication, and he was unable to determine SOC and wanted to do that and learn about and understand his batteries. So he did that by switching to a Discover product. Additionally, this moves him also into the self-consumption possibility. So he really gets into tuning his system and essentially now taking it off grid and living without the grid and using only grid as a backup. So really changing his dynamic of usage. On the last thing here, when it gets to microgrids, these almost always involve reduction of diesel grid consumption. So in this particular sample, this was a remote lodge that ran their system off a 600 kVA diesel generator, which was great during the season when everybody was there, when the place was occupied fully and there were boats at dock, etc., using power. But during the off season, there's really only 1 to 2 people there. Caretaker, a 600 kVA diesel system is massive overkill. They were wasting a lot of fuel just running a very, very small system. So they undertook a project where they installed the battery bank and a much, much smaller generator to charge that battery bank, and overall massively reduced the amount of diesel fuel that they were consuming in this case, and the savings paid for the batteries and the inverter and small generator within 1 season. Going through their second season, they're looking to save enough money to actually add solar to the overall system and begin removing some of the need for that 600 kVA diesel genset in the beginning. So a lot of interesting things, a lot of it that can be done when we start combining diesel and solar and with the use of sophisticated batteries, etc. Really, that's it for me. Thank you for the opportunity. I'm going to hand it back to the folks at Morningstar to close it out.
All right, thanks a lot, Derek. So just to take you the rest of the way through here, show you how easy it is to program Morningstar products for use with Discover batteries through the documentation and literature we provide with our Energy Storage Partner Program. But first, just to talk about some specific, maybe more unique features to our products that help us to address the needs of different lithium batteries. One would be what we call actually our low temperature fold back setting. This is available on some of the newer products, including what you see there is our ProStar MPPT controller. It's also available on the third generation ProStar PWM variant as well. But what it does is it allows you to specify, due to the temperature, especially in cold temperature sensitivity of lithium batteries, what we are able to do is program you can specify a high and a low temperature threshold, basically creating a range that will instruct the controller to linearly derate the output current between those two thresholds. So again, if you have a high temperature threshold of 10 degrees Celsius and you really don't want to charge it below freezing, you can set the low temperature threshold to 0 degrees Celsius. And so then as, temperatures plummet, start going below 10 degrees C, every degree increment, you're going to be operating, basically, you're going to be losing 1/10 of that output current, so that it kind of creates a nice way to taper off the charge to the battery and prevent delivering current in excess of the capacity constraints at cold temperatures. You really don't want to, most of them say don't charge below 0 degrees or -10, whatever it may be. So we can accommodate that very easily. Also, one of the ways to program those settings is through an interactive meter display. which again is available on those same controllers I mentioned, the ProStar MPPT and ProStar PWM Gen 3. So again, those are it's a nice way to make easy settings adjustments on the fly through a user programmable meter display with 4 directional arrows and very self-explanatory menu options to help you navigate that process. We also have a feature where our remote temperature sensor terminals on the controller can actually act as almost a remote switch in some ways, depending on the sophistication of the battery management system being used. Again, Discover offers, one of the more sophisticated BMSs on the market. Some batteries will provide like a dry contact signal to basically give a heads up to any external charging sources when there is an impending disconnect due to high or low cell voltages or alarm conditions within the battery. And so this basically allows, through connecting a relay to the dry contact on the battery management system, you can signal to the controller through our RTS terminals to basically disconnect or stop charging the battery when that condition occurs, which is a nice, useful feature for lithium options. Also, you can program our controller through a meter bus accessory that takes the RJ11 serial port on the controller and converts it to a USB for easy plug-in to your laptop PC. And then you can use our MSView software and edit any changes you want to make to the charge settings. And then again, one other very useful feature for accurate charging in general is to utilize the voltage sense capability, which is not a standard feature on many charge controllers. But again, Morningstar prides itself in taking extra good care of the batteries that are such a precious investment for our end users. And so measuring the voltage directly on the battery terminals and accounting for any voltage drop over a wiring distance between the controller and the battery is the best way to make sure it's getting adequately charged. So again, many of those features will prove to be useful when working with lithium. This is just a graph illustrating the low temperature charge reduction feature, basically, that we spoke about earlier on the last slide. And again, you can just see how some batteries may have a characteristic curve as temperatures start to decrease, and our low temperature fold-back range, specifying the low temperature threshold and the high temperature threshold is a good way to approximate that curve while still, harvesting as much energy as you can into that battery without harming it. So that just illustrates the usefulness of that feature. Again, a few other advanced custom settings that we have available for different use cases. One is high voltage disconnect. This would be a high voltage disconnect protection on the load side. A lot of charge controllers don't have an integrated load circuit, so they can't protect the load from high voltage. But we do for DC loads. And so again, as long as your load rating is within the rating of the controller, you can set high and low voltage disconnect threshold options. Oops, sorry, I think the slides were advancing there. And so you can do that very easily, and again provide that extra security and peace of mind for the sensitive load equipment. We also have a max regulation voltage specification that would provide basically a sort of an added redundancy to make sure that the output voltage to the battery never goes higher than a certain ceiling limit. Again, even if you had temperature compensation enabled, it would never let it go above that threshold. So that's a good, useful thing for peace of mind as well. absorption extension, it's usually more of a useful feature for lead acid batteries, actually, where the absorption duration really varies with the depth of discharge the previous day. So if you had you were really exercising the battery very heavily the day before, you got to a very low capacity, and you want to recover it the next day, it would trigger the absorption extension time interval to override the length of absorption for that day to try and recover any lost capacity from that deep discharge. And again, the ability to modify temperature compensation, again, not particularly useful for lithium batteries, but for other types, nickel cadmium, and of course, the many types of lead acid, the ability to dial that in very specifically, a high degree of accuracy helps, these battery systems last longer. So Derek talked about a little bit about the difference between open loop and closed loop. I just kind of had this here as a placeholder in case it needed some additional discussion, but I think he covered it pretty well. Again, just the main things that we had to keep in mind, because again, our support of Discover Products at the moment is limited to open loop integration, which means there's no communication between our components. Again, when the LYNK system that Derek talked about is released, then that would be a closed loop solution where they can basically assume control of our product and dictate exactly what we need to deliver to the battery. But in the meantime, we are supporting open loop and trying to make that as simple as possible for the end user. So again, minimize the settings modifications needed to actually get going. And so we have created configuration files in our native MSView software that can easily be uploaded to the controller for plug and play integration. And so again, that's what we were after. These are just a list of many of the things we had to keep in mind when we were generating those settings. These are sort of typical requirements for any lithium battery, but also a lot of behavior specific to where the battery may have internal disconnects triggered, either by high or low cell voltage limits, overcurrent, temperature conditions, and that kind of thing. We wanted to mitigate that if at all possible to avoid internal disconnects. We never want the battery to disconnect from our controller while we're still charging. And that's why it's very helpful, if possible, to always have the battery management system either through direct communication or external signaling with a relay or some type of mechanical means to give us a heads up, basically to say, okay, charge controller, you can turn off the PV now. We're going to disconnect from your controller, and again, that avoids any unnecessary complications or potential damage that may occur from that type of scenario when you just suddenly pull the plug on the charging source, where our charge controller is very much dependent on the battery for its power operation. So we have to have that, and we'll try to basically try everything else to limit draw on the battery or prevent harm to the battery before ever pulling the plug on our life supply, essentially. State of charge measurement, again, this is very conveniently offered with Discover batteries with the closed loop option using the LYNK, but also they do have some additional accessory peripherals for state of charge meter displays. I know one was built into the LYNK where it kind of showed you some relative percentage bars of available battery capacity left, and I think those are pretty accurate. So again, they can provide additional information about those components, or you can also use their PC software to get that data directly from the BMS. So now just to show you the how easy it is to set up the controller. All that's really involved is going to our energy storage partner homepage, which you can find under the resources tab on our website. You just click on the brand listed, Discover, and you'll get access to the Morningstar integration guide. It will just ask you to fill out a little information request form for a few fields just to tell us about your application. We're always interested in learning about them. And then you'll get the link to the PDF. Within that link, you'll find the download link for the zip file containing the MSView setting configuration for each supported Morningstar controller. And again, on the next slide, you'll see basically what you want to do is click on that link, and then you'll get this pop-up window. It'll show you again Discover MSView configuration files. You'll click Extract. You can put it someplace where you can locate it again on the desktop, wherever you find most convenient. Just shows you that. Again, you're going to need our MSView software to program it, so you can grab that just from our home page, navigating to the Products menu and scrolling down to the MSView tool. You click on that link, it'll take you to this page. Click on the hyperlink, and that'll initiate the download. And again, you can save that to your desktop or someplace useful where you can find it. And then what you'll do, once MSView is downloaded successfully, you run the executable file, you'll come to the opening screen, you'll click on the Devices menu and click Search for Connected Devices. Of course, you're going to physically connect to the device with a serial connection or Ethernet connection first. But that should be fairly self-explanatory. A window will pop up showing all of the connected devices. You simply select which one you want, press Connect. In the following screen, you'll see that the icon, the device should be recognized by the model name, and then the 8 digits of the serial number. In the left-hand sidebar, you'll see the little green icon, which indicates, again, that you are connected. And then, depending on the type of product you're using, you'll go ahead and navigate to the Tools menu to select the appropriate setup wizard for that product. In this case, the TriStar MPPT setup wizard, so we're going to go in there. And then in this window, you just simply click on the upper left button there, Read from File. And again, on the following screen, it'll ask you to locate that zip folder that you extracted the MSView configuration files from. Go ahead and select. It should automatically locate the specific file for the TriStar MPPT, because it does have the TriStar MPPT file extension on it. So it should automatically recognize which one is appropriate for the device given the setup wizard that you're using. You go ahead and just click Open. When you click Open, you can go to the Edit button if you want, and you can make any additional modifications that you need. If they're application specific, load control requirements you want to adjust or anything like that, go ahead and do that now at this point. And then when everything's gone, you have everything configured the way you want it, you go ahead and just click the Program TriStar MPPT button, and it will push you through to a setup window where it will just navigate you through some prompts that instruct you what to do. And basically, once it'll tell you to power cycle the controller once you've written the settings. And then when the controller comes back up and you've reapplied power, the settings are fully set in. You have the dip switches in the right configuration, and you're off to go. So it's very simple and easy to do. And again, there'll be many more options for additional configuration when we have some closed loop availability with the LYNK system that is upcoming. We're very excited about that as well. So just to wrap things up, I'll just say that really the choice of battery technology, it's dependent on several factors. It's not always a clear write-off that, lithium is going to be the answer in every case. But again, there's definite increasing popularity of those battery chemistries. However, lead acid is still widely used, and it's still a large percentage of our business in off-grid. The expected lifespan obviously has to be taken into account. Maintenance requirements, if it's a remote site especially, and the associated costs with, site visits to perform maintenance, it definitely has to be taken into account. And then, of course, the available space and your budget. You may be able to justify more expenditure up front in hopes of a longer term system savings. Again, it just depends on how you're managing the system's life cycle. So whether it's lead acid or lithium ion, again, each type does require a very specific set of charging requirements, and you want to make sure that it's dialed into your specific battery make and model. Again, through the Energy Storage Partner Program, Morningstar has done that for you. Charge controller settings, again, our MSView software is a very powerful tool to configure a whole list of advanced settings options, many of which you may never find a need for, but they're there just in case you do. And again, we also have some user-friendly features with configurable meter displays and so forth that really minimize your time on site needed to make these adjustments so that you can spend more time getting the system on operational and reduce any downtime. So I guess with that said, I think that pretty much wraps up the core content of the presentation. We'll go ahead and turn it over to Q&A, and I will pass it off to Mark Sarasulo, who joined you at the beginning, and he will moderate the question and answer session.
Thanks, Jake. And we had a lot of good questions coming in during the webinar. Some of them were answered individually during the webinar, but I think we got to just kind of go over a couple of the ones that kept coming up. First of all, and these are mostly for the Discover team, we got questions on if there are altitude limitations on lithium batteries. You want to take that one?
Yeah, I guess that might be one for Brendan.
Hey, sorry, we're trying to get our computers lined here. There are electronics inside the battery. We don't publish an altitude rating, but it is in line with most inverters ratings. So once again, that's due to the electronics inside the battery.
Yeah, if you can't take your inverter charger to a particular altitude, the battery, in our case, the lithium battery will not follow. But a reasonable expectation is probably in the 1,500 meter range on that, which is typically kind of a design target for the inverter chargers. It may go a little bit higher than that.
Great, thanks. And we got another question on rapid shutdown features, which I think Jake will take care of.
Sure. Yeah, so I think the question is here, do we have a solution for a rapid shutdown at the moment? We do not offer a Morningstar specific solution, although we do hope to have one in the future, and we are currently planning that product in development right now. But there are many third-party solutions that would be compatible. We can certainly recommend those to you. It's probably easiest if you contact us via email. That way we can send you documentation on those third-party solutions.
Okay, and we got a lot of questions about temperature characteristics with lithium ion, and I know it's a very big area, but we had some attendees ask if about performance under extremely cold conditions. One attendee mentioned that they Their systems typically exceed anywhere from -40 centigrade to +50 centigrade. And also, what are the challenges and ways to mitigate lithium at low temperature operation? So if you want to come up with a summary of that, that would be great.
Sure, yeah, lots of questions regarding this. I was trying my best to keep up, and I realized it's probably best left to discussion. So lithium can be discharged up to about -20 centigrade. Now you don't want to charge below 0 or freezing. You'll end up shortening the life of your packs. But generally, those are internal temperatures. So there's a lot. It's not the ambient operating temperature we're speaking of. It's the internal cell temperature. So if you've got the current moving and flowing through your packs, they'll self-heat a little bit. So the internal pack temperature won't equal the external pack temperature. So if we have lead acid batteries operating at 40 below, we're going to have some considerations. And likewise with lithium, it's all about evaluating your installation. So if you're expecting that you will be going through a season with constant cold weather operation, it needs to be mitigated with system design, whether that's enclosures. I know heating pads aren't that great, but if you look at the automotive industry, their batteries warm, they're actually heating them. So if you expect to be colder than freezing on a continued basis, and you need to charge down there, and you want to use lithium, there will have to be considerations made at the system level to make sure that our internal temperatures of the batteries aren't falling below that of the freezing level. So I know that's kind of a vague answer around how to deal with it, but I hope that helps shed some light on things. If not, I need to take that answer in a different direction. I'll keep looking for further questions.
No, I think that was helpful, Brennan. Appreciate it. Yeah, I mean, the only additional thing to add to it again on Morningstar's side, that lithium foldback feature can be useful. Again, we hope to see that trickle into more and more future products, just in terms of, again, ensuring that consistent safety and operation of the system when you're talking about charging in cold temperatures has to be done so, very much in accordance to each battery's specific behavior. So again, that's one thing we can do to address it now, but I'm sure there will be other technologies in the future that we can also recommend as well. I'll go ahead and pass it back over to Mark.
Great, yeah, lots more questions. We'll try to get to as many as we can. One excellent one was, how much waste is there after battery death or the end of the lithium battery, and how much of it can be recycled?
Yeah, actually, I actually tried to respond to that, but I forgot to hit enter on my screen. So the lithium recycling process, there's actually a really nice facility here in Canada, up in Trail, BC. So the packs themselves, we can take our electronics out and recycle those through the same means of other electronics. There's lots of gold and what have you there to recover. Most of our bus bar and whatnot is copper, so we're looking to reclaim that, steel cases. And when it comes down to the cell level, they actually go through a similar process as lead acid batteries. So the cell block will go into a crusher, it'll get busted up, goes into a solution tank where your metals sink, your plastic materials float, and your electrolytes and whatnot kind of goes into a slurry solution that's further processed to remove the chemicals from it. I know with lead acid, you'll often see that go off to become fertilizer or what have you. So we recover all our metals through that process. Plastics float, and the chemicals are dealt with. So I don't know the exact recovery rate of that. And it's kind of an interesting area. Lots of conversations come up surrounding this. And I think we'll actually look to the lead acid industry to help solve this problem. So I know a lot of the 12-volt lithium that looks like a lead acid battery, it's commonly getting into smelters, the lead acid smelters, and when it does, it ends up shutting them down, and they need to kind of go in and clean everything out, so it wreaks havoc. So there's a large push from the lead acid industry actually to figure this out, because it's so costly when the lithium gets mixed into their processes. So there are means to recycle, and I can only expect that they will start to become more commercialized as the whole chain's figured out, whether that's, transportation, recovery, the commercial side of it, as the automotive industry and the solar industry and everything else starts to develop and mature.
Yeah, that's a good point. All right, what else do we have?
We have a very good question from someone about if it's advisable to configure depth of discharge at 100% with lithium instead of 80% as they do with lead acid batteries.
Depth of discharge is not a leading factor, let's say, in the lifetime of your lithium batteries. You should be more concerned about the C rate at which you're using them. When we do all of our testing internally for performance and lifetime, it's all done at 100% depth of discharge. So I'd say it's less of a concern of how deeply you're discharging your batteries as opposed to how much current you are continuously pulling or pushing into them.
Okay. Yep, well said.
Another question on reserve capacity and how much do you recommend for, say, cloudy and rainy conditions with lithium batteries?
I think that's a tough one for me to answer. It's more or less up to your system design. So, for example, if I have a threshold where I don't have freezers, I have nothing to be concerned about, I may say I don't actually care, I don't need any autonomy. But if I'm a butcher and I've got, my entire business is surrounded by freezers, I've got a higher threshold for pain there, and I'm going to maybe have 4 to 5 days of autonomy. So I might push back on that question a little bit and say it's more one of a system design and the end user's needs that really dictate that answer.
Yeah, it's a good question. I mean, I've thought about that too, just whether, the old sizing rules of off-grid with lead acid, designing for 3 to 5 days of autonomy, whether, because of the added efficiency of charging, which, enables faster recharging times for lithium, whether that would have any corresponding effect on decreasing the days of autonomy requirement, especially, if you use like oversized solar arrays or, you have really high charging current sources.
And because lithium is so efficient, even if it is a poor solar day, you're still going to be receiving some charge. I'd say one thing to consider though is if you had a lead acid system and you had no autonomy or reserve capacity, and you ended up discharging those batteries for an extended period of time, now you're faced with a situation where your plates are starting to sulfate and you may actually be damaging your lead acid bank. So in that regard, you might have autonomy because you don't want to shorten the life of your investment. With lithium, because you can take them down to 100% depth of discharge, if there's a worry there of damaging your asset, you could turn the system off, wait for that sun to come back, and you haven't damaged anything, if you know what I mean.
Yeah, there's some interesting considerations there. It really is a target from the design perspective. Some of the other layers that you could look at, you target your 2 days of autonomy, whatever hours of autonomy on there, is look up backup reserve capacity, especially if you're doing an AC coupled system out there and you need the inverter charger to be able to start up to bring on the PV array through the AC coupled system. You may want to have additional backup range in your depth of discharge calculations there that is available for the next sunny opportunity to come along and start the system up again. as you may not be able to do that if you've already consumed all battery. That may get into you could do that in a variety of ways, and some products indeed program themselves according to that kind of idea. But that's a designer's prerogative.
Yeah, it's a good point. Well said, Derek. I think, it'd be interesting too to see, what some of the commonly used off-grid solar, PV sizing calculators, how they're adapting sort of their algorithms and models to address some of the benefits of lithium in terms of, again, some of them will, based on your autonomy requirements, give you some type of, I think they call it like loss of load probability, which they can, again, give you in terms of a percentage. So if you have a certain amount of autonomy, whether that will meet your needs and what the probability of that is, of actually losing your loads and having your system go down. It'd be interesting to see what modifications they've made to their algorithms and models to address some of those changes. Good question.
Yeah, great question. Difficult answer.
yeah, of course. See, any other questions we want to take here, Mark?
Yeah, one that came in from actually two that came in from a number of people, and I think it'll be our last question, is how do you get NABCEP credit for the session, and are the slides available? And the answer to that is that these we will send out an email in a couple of days to everybody who attended the webinar, which will have both the access to the slides so you can get the information, and it will have the NABCEP form to be able to get NABCEP credit for the session, which is 1.5 hours. So with that, I think we'll thank everybody for attending. We had a record number of people on this webinar, which was great. You stayed with us for almost a half an hour longer than we had booked, which is wonderful as well. So I think the subject was really, really useful and timely. I'd like to thank everybody for attending, and we'll see you on the next one.
All right. Thanks, guys.
Thanks.
Always a pleasure working with you.
Thank you.
All right. Take care, everybody.
Bye, everyone. Bye.